If you are confused about the idea of repeated zeros, let me give you a couple of simple examples that might help. Hopefully you're familiar with the basic graph of f of x equals x squared. Now let's say that we do a transformation on that equation and we have the graph f of x equals x minus 2 squared, or the equation I should say. That graph is just the graph of the parabola shifted over 2 to the right. Okay, so kind of like this. So notice it has an x-intercept at 2. In other words, if I put 2 into the function, I would get 0 for y. When we have this, we say that this has 2 zeros. And they are both equal to 2 because it has 2 factors of x minus 2. We could actually also say that this has 2 factors of 0. It has 2 zeros, 2 real zeros, and they are both 0. Now what about, and the way you can tell that there is a repeated 0 where there is a double 0 is if the graph just touches the x-axis. Actually, it could be repeated even 4 times or 6 times or any even number of times too, but we're going to just stick with if it touches the graph, the x-axis, it is a double 0. Now what about a triple 0? Let's think about the basic graph f of x equals x cubed. This has the shape you're familiar with for a cubic graph. And notice this point right here where it crosses the x-axis is called the point of inflection because it goes from curving downward to curving upward. And so this point right here is called the point of inflection. We could think of this as x minus 0 cubed. So we could say that this has 3 real zeros and they are all 0. If we were to do the same thing we did with the quadratic graph above and shift it, we could write this as x minus 3 cubed. This whole thing would just shift to the right 2, or sorry, x minus 2 cubed. I think I said x minus 3 cubed. And it would have the same curve. It would still have a point of inflection right here on the x-axis, but it would be shifted over 2 to the right. So we would say it has 3 real zeros, and all of those zeros are the number 2. Now, to differentiate between a triple 0 and a third degree polynomial that only has 1 real 0, but has a similar type of a curve, if the curve would occur somewhere else, okay, so here the point of inflection is right here. Where the graph crosses the x-axis right here is not the point of inflection. So this graph would only have 1 real 0, and the other 2 zeros would have to be imaginary zeros or non-real, 2 imaginary or non-real zeros. Now the reason we know there's 2 is because this is a cubic graph. It has to have 3 zeros. There's only 1 real, so the other 2 would have to be imaginary. Let's just take one more look at imaginary zeros. Let's say we have the graph f of x equals x squared plus 4. So this is a parabola that has shifted up 4. So it's no longer touching the x-axis at all. That means that its 2 zeros both have to be imaginary or non-real zeros because there are no real numbers that make y equal to 0. Remember that a 0 is defined as an x value that makes y equal to 0. So if we set this equal to 0 and solve it, we get x squared equals negative 4. Well, there aren't any real numbers that you can square and get a negative number. If we solve this, it's going to be x is equal to plus or minus the square root of negative 4, which is undefined in the real number system, but it is defined as an imaginary number. Recall the definition of I is that I is equal to the square root of negative 1. And since that is true, if we squared both of these, then -1 equals I squared. I squared is equal to -1. So when we see the square root of -4, it's the same as the square root of 4 times I, or plus or minus 2I. So that means its zeros are both imaginary. We could write this in factored form then as f of x equals x plus 2I and x minus 2I, since 2I and -2I are the numbers that make this function equal to 0. If we were to multiply this out, we would get x squared plus 2ix minus 2ix. Okay, those would subtract out. And then the fourth term would be minus 4I squared. Well, since I squared is -1, -4 times -1 becomes +4. This is where we get x squared plus 4. So going back to this example above here, if this number, this would be our real 0, we would get a factor associated with here, and then we would have another 2 factors that would have imaginary numbers like this one did. So hopefully that helps clear up some of the confusion about real zeros, imaginary zeros, and repeated zeros.